Hello 601. Welcome to my YouTube video for Roshashona. You guys have reached it correctly, which is awesome. You're halfway there. So now what you're going to do is you're going to take the handout that I gave you before break, which I know you haven't lost because you're super responsible, and you are going to fill in your notes as you go along. Now remember, this is a YouTube video, and as you know, because you always watch YouTube videos at home, is that you can pause the video whenever you need to. So make sure that you do that. Make sure you pause it so you can write it down, or that you rewatch the video. Okay, I would suggest you watch the video more than once, but that's just me. Okay? So we're going to be talking about properties. And properties are things that we already know about, but we're going to give them some names. And the four properties we're dealing with are the commutative property, the associative property, the identity property, and the zero property. So properties just describe kind of the way something acts, and in some situations it's going to be multiplication, sometimes it's going to be addition, and sometimes it's going to be both. So let's start with the commutative property, and if you look at this word commutative, you see another word right here. Okay, and here's a hint. When your mom or dad goes to work, or when you go to school, you commute there. Even if you don't go in a car, you commute by train or on foot, which means you move. You move there, and you get there, and you're in a different place. So keep that in mind as we go over the commutative property. It works with both addition and multiplication, and it has two different names for each one. Commutative property of addition is for addition, and commutative property of multiplication is for multiplication. Easy enough, right? So the commutative property of addition, if you take a look here, 2 plus 7 equals what? Okay. Now 7 plus 2 equals what? It's the same thing. Does the order affect the sum? That means if you change 2 and 7 around, does that make the sum different? Does that make your answer different? And the answer would be no. And that's the commutative property of addition. And of course you already knew that, but now we're giving it a name, which you'll have to remember. Okay? And now look down below. The same thing is true for multiplication, except we call it the commutative property of multiplication. And if you see down here, 8 times 5 equals what? And 5 times 8 equals what? It's the same thing. So does the order affect the product? The answer would be no. You can change the order of the numbers any which way, and it does not matter. So get that definition down. The commutative property means that the order that numbers are added or multiplied does not affect the product or sum. And you can see here with arrows that I've switched these around, and they still have the same answer. For addition, it's the same sum of 27. And for the multiplication example, 3 times 7, it's the same product of 21. Okay? Easy. Easy peasy, no problem. So now you need to think of your own examples. This is a good time to pause the video and to write down your own examples so that you don't have to go back and try and figure out what's going on later. So just pause me, and I'll be here when you get back. Alright, let's go on. We finished with the commutative property. Let's go on to the associative property. And if you look at the word associative, again, you see another word, associate. And I don't know if you guys use this word, but when I was in middle school, if I didn't like someone, I would say, I don't associate with her. I don't associate with him, which means what? I don't hang out with that person, right? So if you look here, the green guy, he's not associating with the rest of the group, right? But guess what? How many of them are there? There are 4, correct? If the pink guy was by himself and the green guy was in the group, there would still be 4, right? It doesn't matter how they're grouped or how they associate, but it just matters how many there are. So again, it's not going to change your answer. But let's take a look closer. The associative property works with both addition and multiplication. And again, it's going to be the same thing. Associative property of addition and associative property of multiplication. Make sure you have a second to write that down. Now take a look at the examples. 4 plus 1 plus 10, and the 4 plus 1 is in parentheses. As you know, we do whatever is in parentheses first, so we get 5 plus 10 equals what? 15, right? So now we go to this problem, 1 plus 10 plus 4, with 10 plus 4 in parentheses, and we do the parentheses first. 10 plus 4 is 14, plus 1 is 15, right? So they're the same. Does it matter which numbers are in parentheses if we're adding the same 3 numbers together? Absolutely not. That's the associative property. It doesn't matter how things are grouped or what other numbers they associate with in their little cliques, their little parentheses. It just matters that they're all there and they're all being added together. And down below here we see we have the same thing with multiplication. It doesn't matter which numbers are grouped. See, here we have 3 times 5 grouped, and here we have the 3 times 2, but it's still 2, 3, and a 5 multiplied. 3, 2, 5 multiplied. So the answer is going to be, let's do it here. 3 times 5 is 15, times 2 is 30. 3 times 2 is 6, times 5 is 30. Does grouping affect the product? Nope. So take a look, make sure you get that definition down. There are 2 more examples, and I've highlighted the parentheses so you can see it doesn't matter where the parentheses are or which numbers are inside. The grouping of numbers does not affect the product or sum for the associative property, and that works for addition and multiplication. And now you're going to pause me. I promise I'll be here when you get back, and think of your own examples for multiplication and addition. Make sure you get both. Okay, let's go on to the identity property. And when you talk about your identity, you're talking about yourself, who you are. So I want you to think of yourself looking into a mirror like this guy is, right? And he's looking right back at himself and he can see exactly what he looks like. So keep that in mind. The identity property works with both addition and multiplication. The rules are a little bit different for each guy though. For addition, it's a little bit different than multiplication. And as you can see, it's the same thing. Identity property of addition and identity property of multiplication. You're getting the hang of these titles now, huh? They're pretty simple. Oh, I messed up. There we go. Okay, so for the identity property of addition, you're going to see that any number plus itself, 2 plus 0 is itself, it's 2. 0 plus 8 is itself, it's 8. So which number is acting like a mirror? Which number is reflecting the number? 0, right? It's even shaped like a mirror, so we can see. It's reflecting the 8, and the answer is just 8. So it's the identity of 8 that's we're talking about. And if you look at the identity property of multiplication, it's the same thing. Any number times 1 is itself, so 8 times 1 is 8, and 5 times 1 is 5. So here, which number is acting like a mirror? It's the number 1 that's acting like the mirror, right? So for addition, the 0 acts like the mirror. And for multiplication, the 1 acts like the mirror. You have to keep that in mind. Okay, get that definition down. And there's going to be 2 different definitions. For multiplication, it's any number times 1 is itself. And for addition, it's any number plus 0 is itself. And I've gone ahead in the examples and I've circled those mirrors so you can see for yourself. And I want you to really picture the mirrors because it's going to help you remember identity property. Alright, for the 3rd time, now you're going to put me on pause. You're going to write your own examples, 1 for each. At least 1, but you know I like more than 1. Okay, let's go on to the 0 property. And the 0 property is my favorite property because it's the easiest one. It only works for multiplication, and it's super easy because 0 is the king of all the numbers. 0 rules the kingdom in the number world, right? Because you'll see. So it only works for multiplication, and we're going to see if you can figure out on your own why that's true. Take a look at this. What's the answer to every single one of these problems? 25 times 0, 46 times 0, 12 times 0 is 36 times 0 is 0, 0, 0, 0, 0, 0, 0. So why is 0 the king of numbers? Because if you multiply any number by it, it turns into 0. So 0 is so powerful. It just turns everything into 0. So that's why 0 is the king. And that is the 0 property of multiplication. And again, of course, you already knew that. So we're just giving it a name now. So get that definition down. 0 property means any number times 0 will always equal 0. And I put a few more examples down there. Take a look closely at the third one. I believe that is 24,234,634,230.15 times 0 is 0. And it doesn't matter if I multiplied 10 cats and 14 dogs by 0. It's going to be 0. Everything will be 0, okay? Toenails times 0 is 0. Doesn't matter, okay? Think of your own example now. Go ahead and put me on pause. Alright. So you've just learned about the properties, which is awesome because you're going to be super ahead for class. You're going to be ready to go, and you're going to be ready for our quiz. And don't worry if you don't absolutely perfectly understand everything, because we are going to go over this again briefly in class before your quiz so that you don't feel crazy confused. Thanks for watching, and maybe help a friend out trying to find the YouTube video if you know of someone that needs assistance, because this is our first one. And I will see you Monday morning bright and early, shiny faces, happy to go, ready to go.